What's up, scholars? Today we're talking about circle angles. What are circle angles? Well, they're the angles that arise from the segments that we can create with circles. Oh, very interesting. Also, let's welcome Miss Akin. Thank you so much. It's great to be here. You guys ready to get started? Yeah, let's do it. All right, so circle angles, you say. Well, let's go ahead and draw ourselves a circle, shall we? We shall. Okay, that was pretty good. That was pretty good. Let's call this circle O. I just like using the center as O, don't you? I think it's nice. All right, let's draw a radius. Let's call it OP. And let's draw another radius called OG. OG. Does anybody see an angle? Hey, I see an angle. We made an angle right here. We made an angle using the center of the circle. You know what this is called? That's called the central angle. Now, of course, there are infinitely many central angles. They just have to use the center of the circle to be called a central angle. When we made this angle, we also chopped up the outside of the circle into a minor arc, is what this is called. This is a minor arc. See how it's curvy like an arc would be? We've got a minor arc, and what do you know? We have a major arc. Major arc. So how do we decide if something is a minor arc or a major arc? My major arc kind of petered out there. There you go, pen. Well, a minor arc, let me back up for a second. We all know that a circle is 360 degrees, right? Right. Okay. So these arcs are also measured in degrees, and they also will total up to 360 degrees. So a minor arc is any arc like this, any chunk of the outside of a circle that is less than 180 degrees. Okay, cool. So if I wanted to name this arc, how would I do it? Well, I'm going to use the endpoints, P and G. So this would be named arc PG with the arc symbol on top of it. All right. So a major arc is anything that is greater than 180 degrees. How do we name this guy? Can we also name it PG? No way, Jose. That's the minor arc. For a major arc, we need 3 points to name. So let's call this guy Q. Our major arc then is going to have the endpoints, P and G, but it's got some point in the middle to distinguish it from a minor arc. So a major arc is 3 points, P, Q, G, with the arc symbol on top of it. Awesome. All right, let's say, oh man, I put that Q in kind of a weird position. Let's say we extend our radius and make it a diameter. So Q is close, but not quite. So let's call this guy R. So we've now made a diameter. And in doing so, we made what is called a semicircle. Semicircle, semi meaning half. A semicircle is exactly 180 degrees. Nice. All right, there's some other pretty cool things that are happening here. The measure of the central angle is exactly the same as the arc it subtends. So the measure of the central angle, measure of angle POG, is exactly the same as the arc that it sweeps out. The measure of arc PG. That's pretty neat. How would we find the major arc if we knew the minor arc? Well, we'd say the whole circle is how much? 360. So the major arc will be 360 minus the minor arc. So the measure of the major arc, PQG, will be equal to 360 minus the measure of the minor arc PG. All right, one other cool thing that we can talk about with these circles are called inscribed angles. So let's draw a line from R to G, and let's put another point over here. Let's call it Z. Gonna go through my words, semicircle, sorry about that. And in doing so, we've made an angle that has all of its points on the outside of the circle. This angle that has all of its points on the outside of the circle is called an inscribed angle. So angle ZRG is an inscribed, that E looks kind of weird, inscribed angle, which means all of its points are on the circle. All points on the circle. Okay, cool. So we have central angles that are made with the vertex, and actually we made another central angle. Do you guys see it? Yeah, this one is also another central angle. The central angle's measure is the same as the arc it subtends, so the measure of angle POG is the same as the measure of measure of arc PG. The whole circle's 360, so if you want to find a major arc and you know the minor arc, the major arc will be 360 minus that minor arc. And anytime we have an angle where all of the points are on the outside of the circle, that's called an inscribed angle. All right, Ms. Akin, are you ready to do some Alex questions? Oh yeah, super ready. All right, Alex, what you got for us? Well, it says, in the circle below, F is the center. Ooh. F is the center. Cool. It says GI is the diameter, so that looks like GI is the diameter. And then it says the measure of arc GH is 50 degrees. So that H is right here. It says this right here is 50 degrees. And then we're going to use information to fill out some stuff below. All right. What do you want to know? Oh, there's another chord from I to H in the diagram. They didn't give us any information about it, but it's there, so we should write it down just in case. All right, Alex, you want to know an inscribed angle? Well, I got you, because I know what an inscribed angle is. That means an angle that has all of its points on the circle. So we see angle HIG has all of its points on the outside of the circle. So our inscribed angle here is angle HIG. All right, how about a major arc? Well, a major arc has to be bigger than 180 degrees. Oh, I see. We could say IHG is a major arc. Major arc, HIG. I think I said that backwards. How about a minor arc? A minor arc has to be less than 180. I know that guy's 50, so HG sounds like a minor arc to me. How about the measure of angle GF, oh my goodness, HFG or GFH, same thing. The measure of angle GFH is equal to the arc it subtends. So this guy here is also 50 degrees. Got another one for us? Oh, you want to know the measure of a big major arc here that has the J in it. that we didn't include, did we? No, we did not. It wants G, J, H. Right, that came from here. So to get from G through J to H, oh, okay, well that's just the whole circle minus that little arc. So the measure of arc GJH is going to be 360 minus this little guy, 50, which is 310 degrees. Cool. Should we do another one? Yeah, let's do another one. Show another. Loading, loading, loading. I know it's going to be a circle question, so I'm just going to put it up here. A little bit bigger this time. In the circle below, P is the center, QS is the diameter. So Q to S is the diameter. And then it says the measure of angle, QPR. QPR is 105 degrees. Use the information to fill the blanks below. Got it. Oh, you want another inscribed angle, Alex? Well, I got you. Another inscribed angle. Oh, I'm gonna need to put some more stuff on the picture to match it up. Yeah, I need a T. Here we go. Here we go. Now we look the same. Got it. Inscribed angle just means all the points are on the circle. So let's say QTS. That looks pretty inscribed to me. Angle QTS. Oh, it's so cute. Oh, cutie. How about a minor arc? What's a minor arc? It's less than 180. Well, I know this central angle is 105, so I know the arc it subtends is 105, so I know this is 105 degrees. So, boom shakalaka, my minor arc here is arc RQ. Que fabuloso. What's a semicircle? Semicircle is $1.80. Semicircle happens when we have a diameter. So here's our semicircle, half of the circle, QTS. The semicircle, that chunk of the outside of the circle that's half, is going to be arc QTS. You'd like to know the measure of QTR, would you? Q to T to R, that's a big one. Q to T to R, that's a major arc. That's a major arc right there. So we know the measure of arc QTR is the whole circle minus the minor arc that we know, which is 105. So we know the measure of arc QTR is 360 minus 105, so that's going to be a 5, so that's going to be a 5, so that's going to be a 5, so that's going to be a 2, so it's going to be 255 degrees. Y finalmente, the measure of arc QR. Well, we already figured that out so that we could figure out the major arc. Not even hard. 105 degrees. 105 degrees. Nicely done, scholars. All right, so next we're talking about the angle measure in a circle graph. All right, the question says, in a recent election, there were 6 candidates and 5,100 total votes. The circle graph below summarizes the votes by candidate. So it looks like Watkins and Mendez and Bowerman and DeWitt and Yen and Choi all ran for this office. It says the central angle for Bowerman slice is 32.4 degrees. How many votes did Bowerman get? Well, how much of the circle is 32.4 degrees? So what we're going to do here, you're going to go ahead and copy that picture down. So in your notes, you should have a picture of this. I'm just writing out the work here. We're going to figure out how much of the circle 32.4 degrees is by saying 32.4 divided by 360. So that'll give us how much of the circle Bowerman took up. What does our handy dandy calculator say? 32.4 divided by 360 is only 9%. So Bowerman got 9% of this circle. Not a whole lot there, buddy. Bowerman got 9% of the votes. But how many votes was that? Well, let's multiply by the number of votes. 5100 votes. So we really had, this was degrees, right? They were both degrees, so those cancel out. So we had no units from that. Now our units here should be votes, which makes sense because the question says how many of the votes did Bowerman get? So 0.09 times 5100 is Bowerman got 459 votes. Okay, what did we do? We found the percentage of the circle. So this was the percent of circle, and then we multiplied times the total number of votes. All right, again, in your notes, you will have a picture of that circle as well. Here's the work that goes with it. Alex, would you show us another question, please? Oh, yes, I could do that for you. Fabulous. Nope, I want a whole different one. I want the chart one. Give me that chart one. There we go. All right, chart question. There are 375 books sold last week at Sid's bookstore. The table below summarizes these books by genre. So it looks like we had some romance novels, mystery novels, biography, cooking, and self-help books. The information is also represented in the circle graph. Got it. Find the central angle measure, x, for the self-help slice of the circle graph. Do not round. Okay, cool. In this question, oh, fascinating. It says the mystery section was 27.2% of the circle. It said the romance section is 20% of the circle. The self-help is 22.4% of the circle. It says the cooking is 12.8% of the circle, and the biography is 17.6% of the circle. But we're just asked to find the self-help slice of the circle. All right, pleasantly, they already gave us the percent of the circle. They gave us the percent of the circle, which was 22.4%, which translates to what as a decimal? 0.224. So we need to multiply by the total number of books. Total number of books, which was 375. So let's see what we get with our handy calculator. 0.224 times 375 equals 84. There were 84 self-help books sold. Cool. Let's do one more. Nope. I want another chart one. Give me the chart! Give me the chart! We're getting close. I can feel it. And I love the circle ones, which is fine because we have an example of that already. Is it now? Is it now? Yes, it is. Yes, it is. All right. This says, again, you were drawing the circle in your notes. Last week, there were 350 student absences from Northview High. Come on, guys. Gotta stay in school. The table below summarizes them by the day of the week of which they occurred. Looks like Friday was a rough day for a lot of kids. There were 126 students absent. Also Monday and Thursday, not great. Wednesday though, Wednesday had the least amount. Still way too many absences. Anyway, we're gonna find the central angle X for the Monday slice of the graph. We're not going to round. Okay, I see you. So on Monday, there were 99 people absent out of how many? So we still need the percent of the circle here. But in this case, it's 99, it's not only percent of the circle, it's the percent of students that were absent, right? Yeah. What's the percent of the students here? 99 out of how many? 450 total students. So 99 out of 450 students, 99 divided by 450 is 22%. So 22% of the absences happened on Monday. So 22% of absences on Monday. Kind of a rough day that Monday. 22% of the absences happened on Monday. But it's asking us for the central angle. So we want to know what 22% of a circle is, because the central angle is talking about the measure of the angle within the circle. So we want to say 22%, which is 0.22, times how many degrees are in a circle? 360 degrees are in a circle. So handy dandy calculator says that answer is unrounded 72.9 degrees. So that little slice of pie would be 72.9 degrees. So we found the percent of the students that were absent on Monday, and we multiplied that by the total degrees in the circle to get the total degrees of that central angle. All right, cool. Nicely done, everybody. All right, let's talk about some central angles and inscribed angles. In the circle below, H is the center. Cool. It says we know something about arc FG, so let's finish drawing this picture here. There's an F here. There's a G here. There's an E over here. Wonderful, darling. Wonderful, wonderful, wonderful. All right. We know that arc FG is 106 degrees. It says find the measure of angle FHG. Well, the measure of angle FHG is exactly the same as the arc it subtends because it's a central angle. So the measure of angle FHG is equal to 106 degrees. How about the measure of angle FEG? Well, FEG is an inscribed angle, and an inscribed angle is actually half the measure of the arc it subtends. So let's write that down as some notes. Inscribed angle equals 1/2 the arc it subtends. So that means that angle FEG is going to be half of 106. The measure of angle FEG is 1/2 of 106. What's half of 106? Why, my lovelies, it's 53 degrees. Easy peasy, lemon squeezy. Let's do another one. Show me another. All right. The circle below has a center at S. It says SQR, S to Q to R. The angle is 64 degrees. Clearly, I'm not really drawing this to scale. And then we've got this other guy P here, which looks like it's making an inscribed angle. Do you guys see that? I see it. It's got points all on the circle. All right, Alex, what do you want to know? You want to know the measure of arc QR. Well, that I can tell you very quickly. because the measure of arc QR is the same as the central angle, which is 64 degrees. And the measure of angle PQR is going to be half the measure of the arc that it subtends. So the measure of angle QPR is equal to half of 64. And what is half of 64? Well, you are correct. It is 32 degrees. All right. All right, Ms. Hagen, so what did we learn about today? Well, we learned about angles and circles. We learned about central angles that are made using the center of the circle. We learned about minor arcs, which have the same measure as that central angle. We learned about major arcs that are big guys that need 3 letters to talk about. They're bigger than 180. We talked about semicircles, which are half of the circle. The name of this semicircle would be PZR. PZR. We should name it, right? Let's name it. Arc PZR. We also learned about inscribed angles. Inscribed angles have all of their points on the outside, and they are half of the arc that they subtend. So the measure, let's write this, the measure of arc ZRG, the measure of arc ZRG is 1/2 the arc it subtends, which would be ZG, half the measure of arc ZG. Major arc is 360 minus the minor arc, assuming we know the minor arc. I think that's all that we talked about here. Then we did some examples. We found some inscribed angles, some major arcs, some minor arcs, some measures of central angles, and some measures of major arcs, which was cool. We talked about angle measures in a circle. You guys have the circle pictures that go along with this, right? Yes. So for the most part, we got to make sure our units work out here. We found the percent of the circle, and we multiplied it by time, the total number of votes to get the number of votes that person got. Then we had, it gave us the percent of the circle, and we multiplied it by the time of, multiplied it by the total number of books to get the total number of self-help books that were sold. And then in the last example, we had some students that were absent. So we figured out what's the percent of students that were absent on that one day, and then multiplied it by the degrees in a circle. So this should have been degrees here. So that our final answer was that little chunk of circle would be 72.9 degrees, measuring the number of people that are absent on that Monday. And finally, we talked about some central angles and inscribed angles. Central angle is the same as the arc it subtends, and the inscribed angle is half the arc it subtends. Ms. Hagen, thank you so much for joining me on this circle angle adventure. I love you, scholars. I will see you next time, and keep on that hustle.